Having established the principle behind the 1 in 60 rule and looked at the double track error angle method of correcting back to track, we need to realize that sometimes this method is not the best. It won't work, for instance, if you are more than halfway down track. We need a method of allowing us to proceed directly to our destination after the fix. So, we will now look at how to use the closing angle method of regaining our planned track. In all of the following examples, we will use the word miles to mean nautical miles. Statute miles are very rarely used in aviation. Suppose we are flying from A to B, a total distance of 130 nautical miles. Departure from A was at 1100. The planned track is 355. A fix is taken at 11:15, and we are 5 miles left of track and have flown 50 miles along. We decide that there is no reason why we should not turn directly to the destination, 80 miles away. How many degrees do we need to alter our heading? You can recognize the triangle for track error in the diagram on the screen. We are 5 miles off track, divided by the 50 miles gone, times 60, which is 6 degrees. If we were to turn right by 6 degrees, we would parallel our planned track. Now draw another triangle, this time from the next turning point back to the fix. We have a similar picture to the track error triangle. This time there is 80 miles to go, and we are 5 miles off track. Using the 1 in 60 rule, we can calculate the closing angle. The closing angle is highlighted on the screen. Instead of distance gone, we can use distance to go. So the closing angle is 5 divided by 80 times 60. The answer is approximately 4. By turning right another 4 degrees, we will be tracking towards the destination. The 1 in 60 rule in this case produces the equation that closing angle equals the distance off divided by distance to go multiplied by 60. The total number of degrees to turn through is the track error plus the closing angle. In this case, 10 degrees. The heading of an aircraft is defined as the direction in which the aircraft is pointing. Track is the path over the ground. If there were no wind, then the aircraft heading would be the same as the aircraft track. However, if there is any crosswind, as there usually is, we need to point the aircraft into wind when we try to follow a track. If we get the drift right, the wind will blow the aircraft from the heading we take up onto the required track. In order to remain on track, we need to fly accurate headings. When using the 1 in 60 rule for navigation, we can easily analyze corrections that need to be applied, so that we stay as close as possible to our planned track. Take the previous example, where the planned track was 355 degrees. We calculated that the track error was 6 degrees. Now suppose that the heading we planned before the flight, using the forecast wind, was 360 degrees. Our track made good, which, if you remember, is the path we have actually flown over the ground, was 349 degrees. We know this because the track error was 6 degrees to the left of the planned track, of 355 degrees. So, if our heading was 360 degrees, and our track made good was 349 degrees, we were drifting 11 degrees to the left. Once back on track, we should make use of this information. If we now apply the 11 degrees of drift which we have calculated, then we need a heading of 006 degrees in order to maintain a track of 355 degrees. Previously, we looked at track error angle, and this lesson examined closing angle. We saw that establishing track error angle allows us to parallel track to avoid the off-track distance increasing, but does not close us back to track or to our destination. Whereas establishing closing angle allows us to return to track or to track directly to the destination. In the last example, we found that we had a track error angle of 6 degrees and a closing angle of 4 degrees, giving us a total angle to turn of 10 degrees. This can be calculated in a combined single calculation that does not require the track error angle to be found. Some people find it slightly quicker, and it has useful practical applications. Imagine, as before, that we are 50 miles down a 130-mile track distance and 5 miles left. This time, we don't bother to calculate the track error angle, but we do calculate the closing angle as before. And, as before, we find that it is 4 degrees right. We now take the total leg distance, 130, and divide it by the track distance we have flown, 50 miles in this case. This gives 2.6, or more approximately, about 2.5. Multiply this by the closing angle, and you get the same answer as before. A 10-degree turn is required. So, to summarize, take the closing angle, multiply by the leg distance, and divide by the leg distance flown, and you get a total angle to turn which takes account of both track error angle and closing angle. Let us now summarize what we have done in the last 2 lessons. We stated the 1 in 60 rule and established its mathematical basis. We then used it for 3 solutions to single-pilot navigation problems. These were the double track error angle method, the track error angle and closing angle method, and the combined single calculation method based on closing angle. Most JAA exam questions are solved by use of the second type, the track error angle and closing angle method, but all 3 are useful in practical solo pilot navigation.